Hello, hi everyone. So my name is Aayush Giri. I work as a senior developer at Nethermind, and today I'm here to talk about what we are building when it comes to based rollups. Okay. So so the question is, what is Surge? So Surge is basically a fully decentralized based rollup template, which has stage 2 security from day one, and it operates with a tokenless design using ETH, and it achieves gigagas throughput through Nethermind client, and it employs a 2 by 3 multi-prover security model, all while maintaining complete alignment with Ethereum's core values of decentralization, security, and censorship resistant. So I feel these were a lot of words. So let me try to explain each one of them one by one. And okay, so when we look at Ethereum's scaling journey, we face that what's often called a scaling trilemma, in which we have to compensate one of the three factors and select only two, which is between decentralization, security, and scalability. So most layer 2 solutions make the same compromise, and they introduce centralization to achieve scalability. So this is what they called as a centralized sequencer, and which is basically a single entity which decides how to order transactions. And this creates a fundamental tension between Ethereum's core values and the scalability issues that we are trying to solve. So let's first understand how rollups work, and if by raise of hands, if I can see like how many people know how rollups work in the background. So, okay, so maybe we can explain how rollups work in the first place. So let's begin by understanding why rollups matter and where the current solution falls short. So Ethereum's base layer can process only a certain amount of transactions right now due to its decentralized nature. So rollups emerge as a solution and an alternative to solve this scalability issue by batching transactions off-chain and posting compressed proofs back to Ethereum. This approach has been successful at increasing the throughput, but comes with a critical design choice, which is centralization again. So the basic concept is simple. Instead of executing every transaction on Ethereum, we do that off-chain and post the proofs on-chain. And this significantly increases the number of transactions that we can process, but uh, it does not inherit the decentralized nature because there is a centralized feature involved, which as I said, is a centralized sequencer. So most rollups today use a centralized sequencer model. A sequencer is essentially a single entity responsible for collecting user transactions, determining transaction order, and producing blocks to submit it on Ethereum. Which brings us to problems which these sequencers bring with them. First, it introduces a single point of failure. If the sequencer goes down, the whole L2 becomes broken. Second, it creates a censorship vector, which means the sequencer can choose which transactions to be included in the L2 block and which transactions to be not included. Third, it concentrates power in the hands of the people who are controlling the centralized sequencer. And these guys can take the benefit of the MEV strategies that we know right now happens on the layer 1 as well. So it relies on the reputation system of the L2 as well, which means many L2s claim that right now we have a centralized sequencer, but in future we would decentralize it. And this is the promise that they give us. But we have seen that it has not happened yet with any of them. And this is where the concept of based rollups come into picture. So it's not just a theory, because many people have already established this. For example, like Tycho, Puffer, and some of them. So a based rollup takes fundamentally different approach by eliminating the use of a centralized sequencer, which means that Ethereum's own validators are the people who are responsible for ordering the transactions and block building for the transaction ordering. So the term based refers to based on Ethereum, which leverages Ethereum's existing infrastructure for critical function of transaction ordering rather than introducing a separate layer of sequencing. In this model, user technically submits transaction directly to Ethereum's mempool. Ethereum's decentralized network of validators and builders handle the inclusion of these transactions, and the rollup inherits Ethereum's security and censorship resistant property, which for other rollups is only the security feature, not the censorship resistance part. So it's fundamentally a different approach. Instead of creating a separate sequencing rule or layer, we are using the infrastructure which is already present in the system and using the Ethereum validators. And this is closely tied to the proposer builder system, which is a concept in Ethereum's roadmap that aims to keep block building open and permissionless. So think of it as a Ethereum native sequencing. We are leveraging the existing infrastructure instead of creating a whole separate sequencing layer. So the benefits of this approach are quite obvious by now, which means there's no centralized entity that can censor or reorder transactions. So if your transaction goes into Ethereum, it will be processed by the rollup as well. Second, the security is identical to Ethereum itself. Based rollups inherit Ethereum's decentralization nature. Third, there is no need for an additional infrastructure or governance mechanism for transactions ordering, and you are using what already exists. So there is no separate tooling, there is no separate tools that are required. So base rollups are fundamentally aligned with Ethereum's values from day one, which means they are as decentralized as Ethereum itself because they leverage the same security that Ethereum has. So this approach represents a return to core principles. So decentralization isn't in the future roadmap, but it's based inside Ethereum from the beginning. And this is where we come to Surge. So Surge is Nethermind's implementation of a based rollup template. So it is not basically another rollup, but it is a rollup template that anybody can use to roll up a L2, which can be used by institutions or any other player who wishes to have an based L2. So it is just a research and experimentation showcase by us. And it is designed to showcase what happens when you maximize both performance and decentralization without any compromises. So we built Surge to demonstrate that trade-offs other rollups make are not technically necessary, that we can build systems and scale them without sacrificing Ethereum's core principles. And the 5 key differentiating factors for Surge are, it has a fully based architecture, it has stage 2 security from launch, and I'll be explaining what a stage 2 security means. It has a tokenless design, it has gigagas performance because of the Nethermind execution client, and it has a multi-prover security model, which brings us to a 45-day window. So let's deep dive into what stage 2 security means. So basically by L2 beat, there's a definition given of what a stage 2 rollup should look like, which means it should have no training wheels. And this is the final stage where the rollup becomes fully managed by smart contracts instead of having any centralized entity or any fallback mechanisms. So a 45-day exit window for any upgrades would be required, giving users ample of time to withdraw their funds if they disagree with any changes of the L2. And no emergency powers, which means there's no ability for anyone to force changes without going through the time lock. And limited governance, which means the multisig can only queue upgrades, not execute them immediately. So this means that from day one, Surge provides the strongest possible security that is possible when it comes to building a based rollup. And we are not asking users to trust us, but we are building a system that doesn't require trust itself. And this is in smart contracts it is in contrast to other rollups, which often start with extensive admin powers, and they say that they would be removing these training wheels as they progress in the journey. And so the next term is a tokenless design, which means Surge uses Ethereum exclusively for gas fees and protocol bonds. And protocol bonds come in the consensus part of the Surge rollup. And so basically, these rollups which will be deployed using this template would not have a new token, which means they use ETH exclusively. And this isn't just a philosophical choice. It eliminates misaligned incentives that often come with token economics, which other L2s do usually. And this is the best use case that any institutional level player can have, because usually these institutional level players don't have any tokenomic incentives to take benefit from. So basically it would be using ETH as a gas and for protocol bonds. So the next part is gigagas performance. So what does it mean? It means that it is powered by the Nethermind execution client, which we have in the L2 level. So Surge achieves extraordinary throughput, and we are talking about processing 1 gigagas per second, which is actually proven on base mainnet by the Nethermind execution client. So this isn't just a theoretical claim; it's been demonstrated, and in the version 130.0 release of Nethermind execution client. So the technical improvements that make this thing possible are faster memory pruning that runs in parallel, optimized storage processing, and special speed enhancement for cryptographic operations using advanced CPU instructions. So these are some jargon words. I mean, I don't want to bore you by repeating those things. So the next part is a multi-prover security model, which means that Surge relies on two of these three provers which are involved, which means there is a 2 by 3 consensus model agreement from multiple independent proving systems. One is an SGX based TE, other is SP1, and the last one is Risk Zero's RICO. So this removes single proof point of failure for the system and uses different security assumptions and common vulnerabilities. So the system remains secure even if one prover is compromised. I mean, it depends on the L2 which is deploying this rollup template. They can have more than 3 provers. It's a choice that they have to take depending on the trade-offs they want to do. So together with these innovations, we create a rollup that's both high performant and highly secure without compromising on Ethereum's core values. And I repeat these things again and again, but we have this mission to not compromise on the Ethereum core values for whatever we build at Nethermind. So unlike traditional rollups that chase mass adoption, Surge is not meant for attracting any users, to be honest. Surge is intentionally designed for a specific technical audience of researchers and builders. And we are not focused on onboarding any users or million people onto it. We are focused on showcasing how the state of rollup technology should advance in the future. So this is a research-focused approach by us, which allows us to make design choices rapidly and prioritize technical efficiencies rather than onboarding millions of people. So we don't need to make any compromise to attract users. We can build the ideal system from first principles, and it's already pretty perfect right now, but we still feel that there are some optimizations that we can do. And so Surge serves two key constituencies, which first one is builders and the second one is researchers. So the builders part includes block builders and MEV searchers exploring cross-layer opportunities. For them, Surge offers a predictable environment for transaction inclusion and direct integration with Ethereum's block building process and new MEV strategies or opportunities across layers. And Surge also comes with a cross-layer composability feature, which I'll be explaining later in the slides. So the second part is researchers, where technical teams working on rollup optimizations can work and collaborate with us in terms of protocol design. For them, Surge provides a clean implementation of what a base rollup should look like when it aligns to all Ethereum core values. And this is an open source code that can be studied and modified on GitHub if you would like to see that. So let's talk about another thing which comes along with Surge, which are called Surge power-ups, which are basically plugins for your base rollup, which you deploy using this template. When I say plugins, I want to say that these are some of the features that not every base rollup would require, or the the deployers of that L2 would not want. For example, pre-confirmation and efficient proving and block building and cross-layer composability, because it depends on the use case of the base rollup that is trying to be deployed. So the first power up is pre-confirmations. I can go on to explain what pre-confirmations are, but it would require a separate 30-minute workshop. So think of it in this way, that your transactions are being included on Ethereum L1, as we said, in base rollups. So you would feel that all these transactions would take the same block time, which is 12 seconds, that Ethereum takes, because the Ethereum validators are the one who are including these transactions. So pre-confirmations can be thought of like a bond which someone gives, saying that, okay, your transaction is going to be included on L1, and this is the guarantee that I am giving you. So you get the transaction confirmation within like 200 milliseconds or like 100 milliseconds or maybe even less than that. So and then the second power up is actually optimized proving. So this consists of advanced ZK proving systems that improve efficiency and reduce costs, which will be tailored specifically to the needs of that particular L2. And ZK proofs require typically too much effort when it comes to building the circuits. So by optimizing this process, we significantly improve the performance of the L2 while maintaining security. The third power up is advanced block building. This provides tools for builders to optimize value extraction and transaction ordering across layers. Search-based architecture creates unique opportunities for block builders to coordinate across L1 and L2, creating more efficient markets and reducing negative MEV effects, which actually all of us don't like. And the final power up is seamless layer composability, which in simple words means that we are increasing the efforts in reducing the fragmentation across L1 and L2s. This provides a framework for us to have cross roll-up communication, allowing participants to work seamlessly through all the templates that are being deployed using this, all the roll-ups that are being deployed using this template. So in simple words, I would say that all the base rollups that are deployed using this template can communicate with each other without any bridges or any messaging protocol between them. So Surge isn't actually a product that we want to build and attract users with it, but it's just again, I'm repeating this, but it's just a technical showcase of how good good team of researchers and engineers we have at Nethermind. And it is one of the truly decentralized, high-performant scaling solutions. So we invite you to join us in this journey. So there are many ways in which you can get involved. So you can explore the code on GitHub. You can visit the website using this QR code, which is search.wtf. And you can participate in discussions about the future of based rollups, because that is what we feel the future would look like. And we can continue to push the boundaries of what's possible. So I think like I'm a little ahead of time. So thank you for your time today. And I believe Surge represents an important step forward in realizing the actual principle that Ethereum has when it comes to future roadmap. And I'm excited to see how people react to this technical showcase by Nethermind. And this is what we feel the next generation of blockchain would look like. So thank you.
I think we have a little bit of time for questions. Is there any questions? Anyone? Yes. Right.
Hi, may I understand like search, what language is it based on? And if it's based on Go, then which stack did you actually pull up from? Yeah.
So it is actually based on Go, and I would like to point this out that this is something which we built in partnership with Taiko, which means that we have modified the Taiko stack to be relevant to the changes that we require. For example, the tokenless design, which I said, the multi-prover security model, and all the other features which I mentioned are something which we modified from the Tyco stack. So basically whatever applies to the Tyco stack applies to us. So this rollup template would deploy the L2, which is EVM compatible. Solidity would be used as a language for programming any smart contracts on it. And yeah, I mean, like, are you asking about what is the actual tech stack behind it, like in which language? So it is in Go, and you can contribute to the code on GitHub if you would like to. So we are actually looking for people who are good at researching and engineering, and yeah.
All right. I actually do have a question.
Okay.
So, like recently, you mentioned like one of the benefits of like this base rollup is that it doesn't require bridging between all these base rollups, right? And recently, the super optimistic kind of like ecosystem
OP stack.
are also OP stack is essentially also talking about the same thing. I was wondering whether, because obviously that's another stack, right? And is there a pathway that is very clear for you guys to see like whether these OP or other rollups essentially that are adopting other architectures at this moment to be able to upgrade into base rollups in a simple manner? Because ideally if that is kind of like present and it's just a matter of decision, then it's kind of like easier to gather all the liquidity. Hence the question. Thank you.
Okay, so I feel it would not be possible for these OP stack rollups to shift to being a based rollup, because from an architectural point of view, these are two separate things, and they still need a centralized sequencer when it comes to OP stack. The only thing which OP stack has similar to this is the cross-chain composability feature which we talk about. But in them, it is the cross-chain composability component is coming because all of them are built on the same stack. But in this case, all of these transactions are going through Ethereum validators, and that is the reason it is having this cross composability feature, which means that technically we did not do anything. We are using the infrastructure which is already there, and we don't want to create overburden for creating an L2. So to answer your question, I don't think it would be possible for the OP stack to convert to being a based rollup if they don't make changes on the architectural level.
Yeah, I agree on that one. I was mainly thinking whether it would be an easy change or not. Because if it's an easy change, then, or like some sort of like module for like, hey, just give up on the sequencer, then, whoa, suddenly you are based and ultra based.
Maybe we can try creating a module for the sequencer part, but technically that is the part which is entirely different between these two systems. So it is again a architectural choice that these guys would have to take, that if they want to do this thing or not. Because right now the plugins which I was mentioning about, like pre-confirmations, are still something which is under research by many people in the ecosystem. So it is not something which they can adopt right away. Yeah.
Sounds good. We still have a little bit of time. Another question? One more? Nope? We good? All right, seems like we're good. Thank you, Aayush. Thank you.